Thank you for the introduction. Are you seeing my screen?
Yeah.
Yeah, you're good.
Okay. So, hi everyone. Thanks for having me. I'm Rafa. I am a researcher from CPQD. And my talk will be about optical technologies at CPQD, facing challenges to support future networks in Brazil. So that's our agenda for today. I will start by talking a little bit about CPQD, as I believe that some of you still don't know us. I think it's important to take a few minutes to show you what we do. Then I will show our technology platforms, giving an overview of our areas of expertise. And next year I will present our ongoing activities in optical communications, trying to highlight our goals for optical networks. But I won't go into technical details here. I will just give an overview of our activities. And I will also mention some possible ideas that could be tested on Cosmos. And finally, I will show some of our lab infrastructure. So CPQD is a Brazilian Center for Research and Development of Solutions in Information and Communications Technology. We are located at a high technology park, which also hosts other technology companies. And this tech park is located in the city of Campinas, São Paulo state in Brazil. So here is an aerial view of our facilities. Today, most of us are working remotely, but usually our activities are carried out in those buildings. And here we have a schematic that shows the different types of funding that can be used to finance projects at CPQD. We can say that we act like a bridge connecting academia and industry in Brazil, as many projects are based on advanced technologies from the universities that we help to transform into innovative solutions to meet the market demands. And we can work in projects financed by investments from government and also from industry. And we work around three main strategic themes: smart cities, smart agribusiness, advanced manufacturing, and we employ artificial intelligence and connectivity to provide solutions on these strategic themes. Well, we are in a cultural transformation process, and we are adopting an open innovation model. Also, we pursue leadership in IoT solutions while keeping a sustainable growth. And we act as a partner of the state, and we aim to offer our technologies globally. And all the knowledge generated at CPQD is organized into technology platforms. These platforms gather all the expertise and know-how accumulated in several ICT areas over the course of the CPQD's activity. And today we have 9 technology platforms: cognitive computing, advanced computing, data networks, optical communications, wireless communications, power systems, sensing, embedded electronic systems, and information and communication security. I believe that in each one of these platforms, we are able to find some technology or some application that would be interesting for our Cosmos testbed. For example, we could have a sensors solution from the sensing platform applied in a smart city use case. And we could have security solutions applied in different kinds of transmissions. But in this talk, I will highlight the 3 connectivity platforms, which are maybe the ones that are more related to Cosmos. So in data networks, we are working on network architectures, software-defined networks, network functions virtualization, disaggregation, network management and control, automation. And in wireless communications, we have expertise in long-range transmissions, long-term evolution, 4G, 5G, We also have expertise in local area networks, radio systems, radio frequency antennas and devices, and machine-to-machine and IoT applications. And in optical communications, we work with high-capacity optical transmission, amplification, digital signal processing, and forward error correction. We also work on design and testing of integrated photonics devices and optical networks. So I will give more details about the activities in optical communications, which is my major. So in short, we are always working to increase the optical link capacity to meet the growing demands for data traffic, while keeping in mind the cost and the energy efficiency of the proposed solutions. So in optical transmissions, we have expertise in different scenarios, long haul and repeated systems, no coherency transmissions for short reach like intra and inter data center connections. And today we are also exploring different scenarios for optical wireless communications. And in amplification, we have know-how in different kinds of amplifiers, like erbium doped fiber amplifiers, the EDFAs, semiconductor optical amplifiers, Raman amplifiers. And we have a team working on algorithms to mitigate impairments imposed by in transmission from different sources. Here, our focus is DSP to optical communications, but several algorithms could be adapted to also to wireless scenarios. And we have our optical simulator, the OptraPy, developed in Python. It enables us to evaluate the different transmission scenarios and also to test our DSP blocks. And we also have a team working on integrated photonics. We work on the design of the components. Then we send the components to be manufactured in foundries abroad. And next we test the manufactured device. And in this year, we start to regroup a team to work on optical networks, focusing on control and management of software-defined optical networks. And in addition, we've been applying artificial intelligence techniques in almost all of our solutions, like the optical link optimization, enhance the algorithms for digital signal processing, for the design of integrated photonics devices. And we also want to apply AI techniques to manage elastic optical networks. And today, most of our team is working on a big project called TerraNet. That's a project funded by the Brazilian government, where the main objective is to reach at least 1 terabit per second per channel by working on different areas. So we have work on systemic optimization, where we also have a goal for increasing aggregated capacity by designing amplifiers to support optical transmissions in extended bands. We are working on DSP algorithms to mitigate impairments at the transmitter and at the receiver sides, also to mitigate nonlinear effects. And we are developing advanced forward error correction codes. And in integrated photonics, we are developing active and passive components, and we are going to work on the packaging and experimental validation of these components. And we also have goals for optical networks control and monitoring. And as I mentioned before, we are resuming our activities on optical networks. So for this reason, we are still incipients in this specific area. Then we are studying different data models used in open controllers at the control plane. we are also studying protocols to communicate to programmable optical elements through the southbound interface. But now we are in this study phase, and soon we will work on the algorithms development and implementation. And when it comes to the Cosmos testbed, we are at the very beginning of this collaboration. So we still have no results to show, but we have a few ideas that could be interesting to be tested on Cosmos. And all of these ideas are preliminary, and they are open to discussions. So as general examples, we can use our know-how to put together tests involving wireless and optical transmissions. Also, we have industrial partners that can help us with the use cases and the requirements to put together some pilot experiments. And we can work on AI techniques for network routing, performance optimization, and also for failure prediction. And we can use the CPQD infrastructure to extend testbed capabilities in some experiments. So I believe it's interesting to show you a little bit of our infrastructure. In the optical communications lab, we have components to enable high capacity coherency and non-coherent transmissions. I won't go into details of each equipment, but we have terms of external cavity lasers. We have a digital to analog converter that works at 63 gigasamples per second. We also have high bandwidth modulators, different kinds of amplifiers, a real-time oscilloscope, which works at 80 gigasamples per second when using the 4 channels, or at 160 gigasamples per second using 2 channels. And with these equipments, we are able to perform coherent transmissions up to 32 gigavolts at different modulation formats. And we are also able to carry out PAM4 transmissions at 100 gigabits per second, or also other non-coherent transmissions that could be interesting for data center interconnections, for example. And we have several spools of standard single-mode fibers that allow us to put together a straight line link up to 2,000 kilometers. And in addition, we also have a few hundred kilometers of special fibers with low loss and large effective area that can be arranged in a recirculating loop. And since October 2018, CPQD is also a TIP community lab, hosting trials and supporting projects from the Telecom Infra Project Initiative, in partnership with communication service providers, industries, government institutions, universities, and other players in the telecom market. And we recently hosted a trial using Cassini's and disaggregated cell site gateways related to the Open Optical and Packet Transport project group. And in this trial, we emulated a link up to 2,000 kilometers. And here's how CPQD can be connected to the Cosmos testbed. CPQD is a partner of RNP. RNP is responsible for the Brazilian Research and Education Network. Then CPQD can be connected to Cosmos and to other testbeds around the world through the national and international connections of RNP network. So to illustrate, we are here in the city of Campinas. We are connected to a point of presence in the city of São Paulo. And from there, we can use the M-Light network to connect to the United States. And to conclude, I would like to make a brief recap. I started presenting CPQD, which is a Brazilian Center for Research and Development on ICT Solutions. I showed our 9 technologies platforms, highlighting our connectivity platforms, the data networks, widely using optical communications. Then I presented the ongoing activities in optical communications, particularly in the TerraNet project. And next I talk about our initial activities in optical networks, remembering that we are resuming our activities in this area. I also presented some general ideas that could be applied in Cosmos testbed, but I would like to emphasize that we are very open to brainstorm's idea in this matter. And finally, I showed our infrastructure in optical communications, and I also showed that CPQD hosts a TIP community lab. And that's all I have for now. I'm happy to take questions, and you can also reach me by email or phone at any moment. Thank you all.
Thank you, Rafa, very much. So I was actually putting in the panelist chat sort of question even before you answered it during your talk. So the interesting thing would be to see how we connect Cosmos to CPQD. And you actually touched on that, but just to make sure we are on the same page, I believe you're connected through Florida International University, right? Is that where the fiber from Brazil ends, I believe? Do you know by any chance?
So let me share my screen again, just a sec. So we have a connection to the University of Campinas, and from University of Campinas there is a connection to the University of São Paulo, and the University of São Paulo it's connected to a point of presence that can be connected to the M-Light network, and I know that M-Light network it's connected to Miami. But I'm not exactly the best person to explain this. But if you want to, you can write me later, and I can get more details with the responsibles.
Yeah. So the question is really, I mean, and we can do this offline. So how do we connect from Cosmos through the University of Florida or Miami to you? So yeah, we can take that offline.